Okay, so I'm here to talk to you today about Azure Functions and pitfalls and best practices. So my hope is that for anyone who isn't familiar with Azure Functions, that today you'll be able to walk away with at least some information about where to get started, how to get started, and some of the best practices you're going to want to think about when you're setting up a new Azure Function project. I'm also going to assume that a good majority of you have a really good familiarity with Azure Functions already. So this talk is going to be mostly tailored to some of the advanced techniques and some of the things that I've found successful in my experience about using Azure Functions, and some of the techniques that I've used that I've found that have really been successful for me. And that's with an experience going from like Azure Functions V1 all the way to V4. So I always like to start with an agenda. So first I'm going to talk about just a high-level overview about what Azure Functions is. I'm not going to get too deep into it because I'd like to think that most of you have at least some working knowledge about what Azure Functions is and does and how to work with it. A little bit of background of Azure Functions and how it works. We're going to talk a bit about the triggers, plans and pricing, cost and considerations, and really the meat of this is going to be just tips and tricks. And I've got 7 really good tips that things that you can take away, that you can find that'll be useful in your processes for working with Azure Functions. Then we're going to have a discussion. My presentation is about 30 minutes. We got about an hour, so I thought it was really good for us to be able to have conversations. So what I want to do is I want you guys to be able to think about your tips and things that you think are helpful in your daily best practices. So if there's something that kind of spikes your interest or something that you want to bring to the table, please let me know at the end and let's have a good talk about that, because I really like us to be able to have a shared mindset and be able to help each other out and learn from each other. First off, a little bit about me. I'm the lead architect at Gilson Graphics. I've been working there for about 9 years, going on 10 years now. I've worked in insurance, healthcare, and accounting. Right now, where I work is at Gilson Graphics, a printing company. We have an online ordering system. It's Azure-based. It is a multi-tenant application, which adds to some complexity. Our infrastructure is C#, Angular, and we're in the process of moving to .NET Core. We do a lot of background processes, and we do a lot of batch operations type stuff with data imports and data updates. This makes us a really good candidate for workflows that really fit well into an Azure Function environment. Some of the customers we have, or the ones that you would know, are Meyer, LMCU, GFS, and Army Air Force, Tommy's Car Wash, some of those guys. So I'd like to know a bit about you, because I think it would be helpful for me to know some of your skills. So if I could get a show of hands, who's used Azure Functions before? Great, love it. Who is currently on Functions V1? Good, love it even more. Functions V2, V3, anyone? Great, love it. And everyone else is on V4, I assume? Okay, that's what I like to hear. Okay, we're going to do a quick show of hands. Who's using timer triggers? Good. Blob triggers? Good. Service bus? Good. Orchestrations? Nice, like it. Event grid or other stuff? Interesting, good, okay. All right, so I'm going to buzz through some of the evolution. Pretty sure all of you guys have been burned by this stuff already, but I'm going to go ahead and talk through it a little bit. Azure Functions V1 was released in 2016. It was really based on .NET 4.8, and it was the initial release, right? And this is classic Microsoft, where they release a thing out into the wild and they say, this is the newest, best thing since sliced bread. It's fantastic. Everybody go out and use it. And we all did, and it was great, and we loved it, but it was missing things like dependency injection, right? And there were things that just didn't always work the way we wanted it to, whether that's like package dependencies or things you had to hack to make work, or really there was definitely some things that it was a first generation type release. We moved on to Functions V2 and V3 in 2018 and 2019 with .NET Core. That was iterative. That was a release to start growing the application and growing the framework and using durable function or using dependency injection, scalability, and performance, and getting it onto the .NET Core platform. They did a good job of that. It was incremental. Then they moved on to .NET 4, which is fantastic. So in 2021, they released it for .NET 6, and anyone who is not on .NET, isn't on Functions v4 yet, should be. It's stable. .NET, the Functions v4 introduced isolated processing. So if you don't know that Azure Functions is serverless, they now have isolated workers, which makes it even further optimized. So that way, if you've got one thing happening in one Azure function, it's not going to bring down the other stuff. So the isolated workers were released in .NET 8. The update to isolated workers, we just recently did it we just upgraded from 6 to 8. It was not that difficult. There's definitely some changes there. Things to watch out for is loggers and logging with the iLogger. There's also some decorators that you're going to need to change, and some configuration stuff. So it was not incredibly difficult, but there's definitely some things you're going to need to do in your migration path if you're not on Functions V8 yet. Let's see. Really, it's Functions v4 is really just the standard evolution of where Azure Functions went to. So all that great stuff, that's where you need to be. So I'm going to talk about what are the triggers real quick. And I think all of you already know or have an idea, so I'm just going to buzz through these. Timer triggers using a cron interval, and it's just a reoccurring job. You can use an HTTP trigger, which seems silly to use an HTTP trigger on an Azure function, but I can tell you that there's use cases for this. Where we use HTTP triggers, we often have all of our code base, so we have a certain function that only lives in our Azure Functions project, and we don't want to duplicate it. So if we need to call into it and grab a thing, we'll throw it in an HTTP. So one of the big benefits there is you can secure it, and you can use your master key and use a single key for all of your HTTP triggers. Really easy to call into, and you just pull it in from that perspective. You can also use blob triggers. Blob triggers are great because you could just send it to a text file, parse the text file, parse it as JSON, bring it in, and it's really easy to use. You get to manage those in containers. There's some pros and cons with blob files, so I'm going to get to those in a little bit, but blob triggers are a really good starting point. Service bus triggers, I've actually been moving more of my infrastructure to service bus triggers, and I'm going to talk a little bit more about that in an upcoming slide. But blob triggers and service bus triggers absolutely need to have environmental considerations. And that's going to be one of the things we're going to dig into in a little bit here. There's also orchestration triggers. Orchestration triggers are a bit more of an advanced trigger. And orchestration triggers, also known as durable functions, allow you to do some more advanced functionality for long-running jobs. And that would be a use case where if you expect something to take more than 10, 15 minutes, I think it may even be up to like 30 minutes. But if you're going that long, you should be doing it in a durable function and slicing it down into potentially smaller operations. And in durable functions, you have the ability to create functions within functions and even be able to do what's called a fan out, fan in approach. And I'm going to dig into that in some detail for this topic. Other ones that we're really not going to talk about because I don't have a lot of experience in them is you can do SignalR, Event Grid, IoT, Cosmos. There's all those out there. Lots of good triggers out there. And some of the ones I'm going to talk about are mostly the top ones. So those are the most common. I'm going to quickly talk about pricing plan considerations. It's not much to talk about here. The short answer is it's pretty cheap. Don't worry about it. Long answer, there's some gotchas. If you're on the consumption-based stuff, there's going to be some gotchas. So if you have to do any sort of VPN integration or connecting to your internal network, you're going to have to be on a premium plan. So just expect that that's something that you might run into and might have to deal with. Okay, so now we're getting into the fun stuff. So this is tip number 1, and I wanted to talk about the right way to name your Azure functions. So naming your Azure functions is really important because let's say you go into your Azure portal and you're looking for that function that you're trying to work with. Well, you can search for it and that's fine. But let's say you have a durable function and your durable function has like 4 things. Well, you should name those in a sensible manner so they're grouped. Now, what's also important is keeping those in logical groups and naming them in a consistent way. And so the naming scheme that we've used, that we've started using in everything in our functions E4 has largely been, we have, number 1, we have a variable at the top with a job type name. And then we put that parameter into as a variable for our decorator. So you can see here that we have a function name, job type name, and then the type of the trigger. So in this case, you would have your decorators with the function, job type name, trigger. So for consistency's sake, you've always got your job type name at the top, and then you just bake it in with the with your noun, the job type, some sort of prefix, and then what it's actually doing. And we're going to start seeing this pattern build up as we're starting to get into the durable functions, because it gets really important there with understanding the workflow about where things are flowing through. And it's really handy to be able to do your strings and build up the string within your decorators. So here's some examples of the naming schemas that we've used and how this is really handy. So we use a batch operation is really a bucket group for how we do background operations and background jobs. And so I'll show you some of this, but our batch operations are largely just generic requests that are saved out to Azure storage that are backed up with some metadata about it. And then we slice and dice it down to batch operation items. So this is a schema that we're using, a generic schema, but each of these is a batch operation. So these are grouped by a type. And we have some of these that are just generic background jobs that are reoccurring. So we have delivery status jobs, we have shipping status jobs, then we have group orders here. And this is a durable function grouping with group orders, and another grouping for durable functions. And we're going to unpack these in a little bit. So this is my second tip, is use your environment variables. And just understanding where your environment variables are going to be important. This is really critical when you get to talking about blob triggers and service bus triggers, right? So a great way to do this is just having your blob environment inside of your decorator, and just have that as an environment variable. And it's really easy to do. You can also have your service bus queues initialized with environment. We have, for our application, we have a single service bus instance used by all environments because we don't care. We're just dumping data out there. And the queues are environment. And each of those queues has an environment prefix. It has environment prefix and job type name. And it's that simple. When you talk about HTTP triggers, timer triggers, orchestration triggers, it doesn't matter. Event grid, I don't know anything about event grid. Good luck. So this is just some screenshots with examples of how that works. You can see in the decorators, we've got blob environment, and you can see here, for ours, we use a local dash as the default. So this gives us the ability, so if I'm local Neil, I'm not stomping on somebody else's local Tony. So that's a really good, been really handy for us, and has been really successful for our needs, so we're not robbing each other's queues and stealing each other's blob files during a local development scenario. Tip number 3, create a unified job request funnel. So one of the pitfalls that we found with blobs is that with all these blob folders, you never know what's going on. How do you know what's in all of these blobs? And so we kept having these questions. Where is this thing running? Why is my thing not picked up? Has it failed? Has it stopped? Why isn't it done yet? Well, then we got to either A, go out and look for the thing, B, open the folder, so it becomes a scavenger hunt of like, are there other things running? And so you get into this monitoring ability. So what we created and what we really found successful is, let's go here real quick. So this is an example of a unified job request funnel. Now you'll notice this is a blob request queue. It is the only blob request queue in our entire application. That's intentional, because what we do is we funnel it with, first we have a standard request, that's a function request. Within that function request, we have a standard object, which is our queue name. That queue name gives us the ability to funnel it out. And then we have an enum every time we create a new task to say, do our Azure constants with the durable task queues contain the queue name? Well, if it doesn't, then it's a service bus queue, right? So step number 1, is there a queue name? Standard validation. Yes or no? Don't pass go. You're done. Step number 2, is it a durable function? Yes or no? Is it part of that enum? Yes or no? If not, move on. Finally, it must be a service bus queue. Send it to the service bus queue. So what this does is this gives you a single funnel, a single request pipeline. And this is really simple. And it's like it just funnels it out to its appropriate places. And obviously what we're using is we're only using durable functions and service bus. And so that's been really helpful for us. The other thing is, for local development and retestability, you throw a breakpoint here and you just grab the blob file, resubmit, resubmit, resubmit. So that way it gives you the ability to do a quick iteration retest. And you could just fire it, fire it, fire it. So it's really handy. The other thing I want to talk about is, this is 3.1, so I'm cheating a little bit, but I just wanted to say beware of blob containers. There are some pitfalls with them. They can be difficult to monitor. Like I've said, I've gotten questions like, why is it stuck? Did it fail? Tracking, auditability, you literally have to go out and like have a list of all of your blob containers. Where are they? Where is my thing? Has it failed? I don't know. You also have to do things like rebuild the container. We've all done containers in there, but what we really want is directories. Those directories wipe out when there's no files in there. So if you need to create something, you're constantly like, if you want to do it manually, it takes time. So it's cumbersome. And then you get into whose responsibility is it to manage those blob files? Do you take that responsibility? Do you delete those blob files? Do you move them along a process? And then what if you wanted to chain operations? Are you now managing a blob file with a pending blob file to a processing blob file to a init blob folder? I mean, you're moving these blob folders around, which can work, and we've done it before, but some of the lessons that I've learned about blob folders, if you're chaining operations like that, you really need to be using orchestrations and durable functions. So I want to talk about monitoring tools. I don't care what you use something. Do it early, find a good solution for it. Azure Functions, one of my criticisms of Azure Functions is they do not have good monitoring. Which we'll get to a little bit about that later, but build yourself monitoring from the get-go. I don't care if you use App Insights. I'm not a huge fan of App Insights. I've struggled with it. It's brought down my application before because it was misconfigured. Yes, we'll own that. But once burned, twice shy, right? I use transaction logging. Transaction logging is custom hand-rolled logging. So I write my own stuff to the database and I'm responsible for purging that data. But I build my own metadata. And that transaction logging has a column for job type name. So if I'm looking for a specific function background job, I can just query, give me the transactions for that specific job type name. So purpose built for exactly what I need. Yeah, rolled my own. But you know what? Satisfies exactly what I'm looking for. I'm also going to talk about Durable Function Monitor, because for those who are using Durable Functions and have never seen this screen, you're missing out. So Durable Function Monitor was written by a Microsoft employee. So this is a tool that you can just pull down and deploy directly from the Git repo with Azure Identity. And you could just have a monitoring dashboard for all your durable functions. So this is all of our shipping status stuff with all completed successfully. And now you're going to ask, well, what does it look like when it fails? Well, this is a success. This is a failure. So we can see we've drilled into the detail here, and it failed. And here we have the stack trace. And I can go to exactly the line number that it blew up on, like it did 2 days ago. So this is how we can get some monitoring around Azure Functions, because Azure Functions does not provide you what you really, the transparency that I would love to see in a future iteration of Azure Functions. So now we're going to dig into to the larger section of this presentation, and that's talking about durable functions and orchestrations. I want to focus on the fan out, fan in pattern, and the use case for this is if you need to do something and you need to process a lot of things, you want it to happen fast, you want it to happen in parallel, and you're not worried about any of these things colliding. So for my use case, I have an order import. I initially had an order import operation written in Hangfire. Took 2 hours to process because it was happening on a single server and it was happening in sequence or as a single job. I don't remember. We moved it over to Azure Functions v1, and I think that brought it down to about an hour, and that was pretty good. We doubled our time. Got it onto .NET Core. It runs in 5 minutes now. Well, .NET Standard, I should say. And the way we got that was the durable functions, fan out, fan in, and the performance of .NET Standard. It's fantastic. You know, I can tell you that I had a lot of great success. Number one with .NET Standard, .NET V8, and the durable function pattern. With that said, there's some code plumbing to it, and there's some complexity. So I want to talk through some of the patterns and how that works for here. So this next slide is not how you should do durable functions, but I asked AI to write me up, to create me a linear workflow with a graphic-based representation with a linear progression of these actions. So I want to walk through these actions. So this is what AI came up with of what a durable function looks like. Sometimes this is what it feels like, but if anybody has a finalized Purity, let me know, and we'll try to get that worked out. Here's some other fun ones of what you could be doing with durable functions. I'm not really sure how, but AI seems to think that all of that is a good idea. What I did was I wanted that, and so this is what I do with durable functions. This is my fan out, fan in pattern. And you can see here that following the naming schema, we have the job type name, order import, And we've got the trigger. This is where it comes in. You do some init activity. This comes to parsing. Activity is where we're fanning out. We're bringing it back in with the finalize activity. And then we have a shared durable function that all of our durable functions go through that says, did it succeed or fail? Do some finalize operation with sending email. So this is what this looks like. As I've warned you, code plumbing, but I've tried to highlight some of the things I want to talk about here. So this is the trigger piece, right? So this is where it's all started, and this is your orchestrator. And you can see here the task orchestration context. So if you think about this, like if you're in an orchestra, right? This is the orchestrator at the front, right? He's coordinating things. We're coordinating what's going on here. So you've got the job type name here. You're parsing the input with deserializing it to a standardized request property, initializing it. Step 2, so we go trigger over to the init activity. So this is where some of the pre-processing happens. So we could do some initial validation there. We just slice and dice it and do some like initial processing. Once we have those initial records, we can fan out, and that's where this loop comes in. So we create parallel tasks, and we're running these in parallel with the activity, calling it async, and we can also return an ID. I'm not using it in this case, but we have the ability to do that. So if we say, do we need all of the IDs for what returned? Yeah, we got it. We can also define our retryability. How many times do we want to retry that? So you can define that as part of your process. Next, it's fanning back in, and that's where we get our finalize activity. For my purposes, that would be calculate order total. So if I've got 100 orders, I need to calculate what those sum total is. I do that at the end. Or I need to ship it down to a downstream system. So if I need to send the order to the downstream system, I'm going to do that in my finalize activity. Finally, we have finalize orchestration. And from our purposes, this is where we're handling the email. So every time we look at the end of a job and say, did it succeed or fail? And we standardized it enough with the batch operation schema that says, if one of these activities within this pattern fails, it's marked as a line item failure. And then we roll that up and send out an email to the requester and said, did it fail? Send out a failure email. And we handle catch exception, and we also finalize it and fail it no matter what. So this is unpacking the init activity. It's largely what I described. And so for this purposes, number one, we are using SignalR for loading status and percent complete status. And I'm going to talk a little bit about that more later. But here you can see progress bar updates. We're setting the status to processing, and then we're doing parsing and returning the array of details that we parsed out from an Excel file. Next, this is the meat of it, where the activity is actually happening. So you can see that we're returning just our ID, just an activity trigger. We're processing the order. We're returning the order ID. If it fails, we're setting the item status to failed on that single item, not failing the entire job. It's failing the order item. And finalize activity. Not a lot going on there, but you can see we're doing things to finalize the task. Any roll-up activities you need to do. We have vendor quantities that we've got to manage. You can do whatever downstream stuff you've got to deal with. That's where you're going to do it. Finalize, we're setting the status for the overall job to complete. So if you're curious what the data structure for our batch operation schema looks like, this is it. So you've got a metadata for the larger batch operations file, where we're storing a blob file of the Excel file. And then you can see here This is one job of many. So these are like, these would be an individual order record. So if your import has, well, in this case, like 5 records, this would be where to download the source file from. And this would be, after we parsed it, we have all of these itemized records for, that is just parsed out, the Excel in the JSON format. So we don't have to worry about it. We also have the result of the individual line item for the individual order and what it looked like. So next I want to talk a little bit about Azure SignalR. I know this is a little bit off topic for Azure Functions, but I think it goes back to best practices for Azure Functions. Azure SignalR, specifically serverless Azure serverless SignalR, is fantastic. It's super easy. This is what we do for a loading screen. You can see loading progress. This is an Angular app. You can get loading bars. And this is what the code looks like. So this is adding progress logs, how it looks like within our activity, where we're adding the progress. You can add it completed and failed status. And this is what it looks like for the actual implementation for Azure Serverless. We're looking at like 20 lines of code. So we're not talking about infrastructure. This is not SignalR hubs. If any of you have done SignalR hubs in the past, they're a pain in the butt to manage. Don't do that. Azure Serverless is fantastic. And it doesn't take a lot of code, doesn't take a lot of effort. It's like 20 lines of code. So do that too. That's great stuff. So my last tip is use other tools. I love Azure Functions, and it's a tool in your toolbox. With that said, there's other tools that you should have in your toolbox. Azure Functions is not the only game in town. In fact, we've used Hangfire in the past. We struggled with Hangfire because our infrastructure required multi-tenancy. And when we used that in .NET Framework, .NET 4.8, we struggled because of Unity resolution. Now, here we are, and we've moved most of our stuff to Azure Functions, and we're getting ready to re-implement Hangfire in standard. So now we're going to have 2 background processes. So what I love about Hangfire is the dashboard. If you've never used Hangfire, Hangfire is a fantastic tool. It does things a little bit differently. It's a single server processing, and it might be a little slower, but it's really easy to work with. The dashboard and the retry is fantastic. You can even do a lot of what you do with durable functions with like grouping processes with the paid version, with batching. It's not that expensive. It's a great tool. Highly recommend Hangfire. I'm not saying it's better or worse than Azure Functions. I'm saying that there are other games in town, and use the tools that you have. Hangfire is an awesome one. I'm also going to give a shout out to Azure PowerShell. There's a lot of good background operations and tasks that you can't do with Azure Functions, specifically around managing things in Azure. We use a lot of Azure PowerShell for things like backing up our database. So we have a nightly job that just says backup database, throw it out to a blob server. It's great. I know that we all have 30-day rollbacks for Azure, and all that's fantastic. But if I want to have peace of mind, be able to say, where do I download that database? I know where to point to. The other thing that's handy is, number one, if a new developer starts and I say, go grab this copy of database, especially in a multi-tenant application that says, we have 50 different tenants, go download that one. You can do that really easily. The other thing that we also use it for is DNS propagation, creating, so we have Azure DNS, which is fantastic, creating our SSLs, building out the custom domains, you name it. Azure PowerShell can do it. It's really powerful stuff. You pretty much find anything you want to do in Azure PowerShell. It's a great tool in your toolbox. So let's see. What else? Thank you. So that's my presentation. Thank you for listening. And so if you need any of those code snippets, you can grab it from there. And so it's all good.